In this episode, we focus on a skill that separates vague security intentions from security that actually gets built and maintained, translating what an application needs for security into clear requirements, and then proving those requirements are accounted for using traceability and architecture documentation. A lot of beginners picture application security as a checklist of controls, but real systems do not become safe because someone said the word secure in a meeting. They become safer when you can explain what must be protected, what threats matter, where those protections live in the design, and how you can show that nothing important was forgotten. The heart of the topic is turning messy, human concerns like protect customer data or prevent fraud into concrete, testable needs that designers and developers can implement without guessing. Just as importantly, you learn how to keep those needs connected to the system's diagrams and documents so that when the system changes, security does not quietly fall behind. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful way to begin is to understand what it means to translate security needs, because needs are often expressed at different levels of detail depending on who is talking. A business stakeholder might say the app cannot leak customer information, while a compliance stakeholder might say the app must meet regulatory expectations, and an engineer might say the app should use encryption and authentication. None of those statements are wrong, but they are incomplete until you identify what data is involved, who uses the app, what actions matter, and what could go wrong. Translation is the process of taking those high-level statements and converting them into requirements that a system can satisfy, like how identity is proven, how access is granted, and how sensitive actions are recorded. If you skip translation, teams often rush to implement familiar tools and patterns that do not actually address the real risks. That is where expensive security work can still produce fragile outcomes, because the security measures are not connected to the real need. Once you start translating, you quickly run into the idea of traceability, which is how you show that a requirement is not just written down, but actually connected to design and implementation. Think of traceability as a set of threads that tie together four important things: the reason you need a control, the requirement that states it, the design decision that places it somewhere, and the evidence that it exists. A common artifact for this is a requirements traceability matrix, or TM, which is simply a structured way to map each requirement to where it is addressed and how it will be verified. Beginners sometimes worry this is paperwork, but the value is practical. It prevents the team from forgetting important requirements during redesign, rushing changes, or adding features without thinking through security impact. When the system grows, traceability becomes a memory that does not rely on one person's brain. In security architecture, the ability to show those connections is often more important than having perfect wording because it proves the security story holds together. Architecture documentation is the other half of the topic because you cannot trace requirements effectively if you do not have a clear picture of what you are building. At a minimum, you need a description of the application's components, how they communicate, and where data flows. You also need to know what is inside the application boundary and what sits outside it, like external identity providers, payment services, or analytics platforms. Beginners sometimes confuse architecture documentation with big formal diagrams, but it can be as simple as a clean, accurate set of diagrams and notes that reflect reality. The key is that documentation must be understandable and stable enough to support decision-making, especially around trust boundaries and sensitive flows. If the diagrams are outdated or hand-wavy, traceability will be misleading because you will be tracing requirements to a picture that does not match the system. Good architecture documentation is not an art project, it is a shared language. A practical translation process starts with identifying what the application is trying to protect and why. That usually means describing the kinds of data involved, such as personal data, payment details, health information, internal business records, or intellectual property. It also means describing what actions matter, like account creation, password reset, money movement, access to reports, or administrative changes. Even for a beginner audience, it helps to think in terms of consequences. If this data is leaked, what harm occurs, And if this action is abused, what damage occurs. Those consequences help you decide which requirements deserve strong protection and which can be lighter. If everything is treated as equally critical, teams either overbuild and slow down unnecessarily or underbuild because the scope feels impossible. Clear translation is about choosing the right level of protection based on what is truly at stake. From there, you can connect security needs to common categories of application security requirements, without making it about tools or configuration. Identity requirements define how users and services prove who they are, and they often include multi-factor concepts, session handling, and account recovery. Access control requirements define who can do what, under what conditions, and they should describe roles, permissions, and constraints in a way that is consistent with business rules. Data protection requirements define how sensitive data is handled at rest, in transit, and during processing, and they should be precise about where data is stored, cached, or logged. Monitoring and audit requirements define what must be recorded, how long records are kept, and how records support detection and investigation. Each category is a bridge from a human concern to a system behavior, and the translation must be specific enough that designers cannot interpret it in conflicting ways. Traceability becomes powerful when you tie requirements to the architecture's key views, especially component diagrams and data flow diagrams. If a requirement says only authorized users can view customer profiles, the architecture should show which component enforces that check, such as an application layer service or an authorization gateway. If a requirement says sensitive fields must not appear in logs, the architecture documentation should identify logging points, log collectors, and the data paths that might carry sensitive fields. If a requirement says certain actions must be auditable, the architecture should show the audit event pipeline, storage location, and who can access the audit data. This is how you avoid a common failure where a requirement exists in a document, but no one knows where to implement it, so it gets implemented inconsistently across services. When the trace points to a specific place in the architecture, ownership becomes clearer. When ownership is clear, security becomes maintainable. Another important beginner concept is the difference between functional requirements and security requirements, and why traceability helps them stay aligned. Functional requirements describe what the application must do, like allowing purchases, showing account history, or supporting a support agent workflow. Security requirements describe how safely those functions must operate, like requiring strong identity before purchase, restricting account history to the correct user, and limiting support workflows so they cannot be abused. If you treat security as separate, you get security controls that block legitimate use or functions that bypass security. Traceability helps because it lets you map a security requirement to the function it protects, showing that the requirement is not random. It also helps highlight where a new feature creates new security needs, because new functionality changes threat opportunities. In simple terms, traceability prevents security from becoming detached from how the application actually works. Architecture documentation also supports threat thinking without turning the episode into a specialized threat modeling workshop. When you have clear data flows, you can spot where data crosses boundaries, where identities are asserted, and where untrusted input enters the system. Those are the locations where security requirements matter most, because they are the places attackers tend to target. For example, an external interface that accepts user input needs requirements for input validation and abuse resistance, while an internal admin interface needs requirements for strong authentication and strict access control. A message queue that carries sensitive events needs requirements for integrity and confidentiality, while a cache needs requirements for preventing sensitive data exposure. Without architecture documentation, these decisions are guesswork and memory. With documentation, they become visible, and that visibility is the foundation for effective translation. A frequent misconception is that documentation and traceability slow everything down, but the real slowdown happens when teams discover late that security expectations were unclear or contradictory. If requirements are vague, different developers implement different interpretations, and then security testing finds mismatches that require rework. If architecture documentation is missing, teams make changes that accidentally remove controls, like bypassing an authorization check in a new service path. Traceability reduces these surprises by making assumptions explicit early when change is cheaper. It also supports communication because instead of debating opinions, teams can point to a requirement, a diagram, and a verification plan. For beginners, it helps to see that the goal is not to produce documents for their own sake, but to prevent invisible drift. Security drift is when the system changes, but the security story does not get updated, and traceability is one of the best defenses against it. Verification is another key part of translating application security needs, because a requirement that cannot be verified is difficult to trust. Verification does not mean writing commands or running tools in this context. It means defining how you will know the requirement is met. Some requirements can be verified by inspection of design, like confirming a sensitive data flow is protected end-to-end. Others can be verified through testing approaches, like confirming that unauthorized users cannot access protected functions or that sensitive data is not present in logs. Traceability ties each requirement to its verification method, which prevents the common problem of having security requirements that no one checks. When verification is planned, teams can build tests and reviews into their lifecycle rather than scrambling at the end. This also helps with accountability, because a requirement that is verified has evidence, not just hope. Evidence is what turns security from a belief into a demonstrable property. As applications evolve, change management becomes one of the biggest reasons to use traceability and architecture documentation. Every new feature can introduce a new data flow, a new trust boundary, or a new role, and each of those can create new security requirements or alter existing ones. If you have traceability, you can look at a proposed change and quickly identify which requirements might be affected, which diagrams need updates, and which verification activities must be repeated. Without traceability, teams rely on tribal knowledge and informal memory, which fails when people leave or when multiple teams contribute. Architecture documentation also helps new team members understand the system's intent, including where security controls are supposed to live. A system that depends on unwritten assumptions is fragile because it cannot scale across time and people. Traceability makes security a property of the system, not a property of a specific employee. It is also important to recognize that application security needs often span beyond the application itself, which is why architecture documentation must include external dependencies. If the app relies on a third-party identity provider, requirements should describe what the app assumes about identity tokens, session timeouts, and account recovery. If the app uses external payment processing, requirements should describe what data is permitted to be stored locally and what must be delegated. If the app calls external APIs, requirements should define authentication, authorization, and integrity expectations for those calls, including how failures are handled safely. Traceability should connect those requirements to integration points shown in diagrams, so it is clear where assumptions are made. A common fragile design is treating external services as a black box and assuming they solve security for you. The safer approach is to document assumptions and trace them to controls and verification. Another subtle but valuable translation skill is learning to write requirements at the right level of abstraction. If requirements are too high level, they become slogans, and slogans do not guide implementation. If requirements are too low level, they lock the team into a specific design or product choice, which can become obsolete or inappropriate as the system changes. Good security architecture requirements often describe outcomes and constraints, like requiring strong authentication for administrative actions, requiring least privilege access for data retrieval, and requiring protection against tampering for audit records. They also define boundaries, such as which components are allowed to access which data and under what conditions. Traceability then ties these outcome-focused requirements to design elements that implement them. This balance keeps security requirements stable even as underlying technology evolves. Stability is especially important for beginners to appreciate because security is a long game, not a one-time build. When you put all of this together, the big picture becomes clear. Translation, traceability, and architecture documentation form a loop that keeps application security grounded and durable. You start with needs and risks expressed in human language, translate them into requirements that describe secure behavior, map them into the architecture so they have a real home, and define how they will be verified so they can be trusted. Then, as the application changes, you revisit the loop, updating documentation, checking traceability, and re-verifying the requirements that might be affected. That loop prevents the common pattern where security is strong in the initial design, but weak after a year of feature growth and team turnover. It also teaches a habit of thinking that is central to security architecture. You do not merely add controls, you explain why they exist, where they exist, and how you know they still work. That is what it means to translate application security needs in a way that survives reality.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.